So now we've got gravity, the force of gravity, and the electric force. The force of gravity, if you'll remember, is Fg equals what? Big G divided by r squared. There we go. So that's the force of gravity formula. There is another formula that you may need. I honestly have never used this formula in my life, but it's on the formula chart, and that's the formula for universal potential energy. If for some reason there is something that is not near the Earth's surface, you can find the potential energy of it by doing this. The potential energy, U, remember they have weird potential energy sign, is equal to big G M1 M2 divided by R. That's how you find the potential energy. Like I said, I have never used this formula in my life. I don't know why you would, but like for instance, if an object was on Mars 5 meters in the air, you would have to use this formula because the gravity would be the same, right? The acceleration due to gravity would be the same on Mars. Anyway, can't imagine why you need it, just in case. There was also a formula that was the electric force equals K Q1 Q2 over R squared. K, remember, is 9 times 10 to the 9th. What is G, capital G? 6.67 times 10 to the negative 11.
I don't know why.
And K is 9 times 10 to the 9th. All right, so if you'll notice, both of these formulas are similar to each other. They're not exactly the same, but they are similar to each other. So they follow similar patterns. So for instance, if you're trying to solve, most of the time, if they're asking you to plug in numbers, it's not all that difficult because you're really just plugging in the numbers where they go. There is a couple of times on this formula that it can get complicated. Remember that if you are trying to figure out the acceleration due to gravity of a planet, or at a certain point, G can be equal to big G times the mass of the planet divided by the distance from that planet squared. So like, for instance, if you're a satellite orbiting Earth, right? Satellite orbiting Earth has a different gravitational attraction to the Earth than you do because it's farther out. If you need to know that, you can use this formula. Also remember that when we talked about circular motion, we talked about it and we said that big G, or sorry, the centripetal acceleration holding the object in orbit was this acceleration. Y'all remember doing that? Where if something's in orbit, the G is equal to the acceleration. Or you could do the centripetal force is the force of gravity on that object at that point. And so you could use this formula to find the centripetal force. Do y'all remember doing this? All right, just a little brief reminder. These two formulas, though, also have this in common. They have the 1 times 1 times 1 divided by 1 squared thing, right? Do you remember we did this? Okay, so what would happen if I doubled my masses? Okay, so what would happen if I doubled my masses? Well, you would plug it in instead of 1 times 1 times 1, it would be 1 times 2 times 1 times 2 times 2. Okay, and you would get 4 times. So what that is, it means your force is 4 times greater. If your original force was 200 newtons, what would this new force be? 800 newtons. Okay, so let's double my masses. What about I half one charge, triple the other, and cut the distance to 1/3. All right, so this is a complicated one. Lots of stuff happened. All right, so what happens if I half one charge? What would I do? 1 times 1/2 times 3 divided by 1/3.
Oh,
Is 1/3 what? Squared. You gotta square it. Don't forget to square the bottoms on these. So you would get 1.5 over 1/9. And if you brought it up, you would get, what would this be? What's 1.5 times 9? I can't math. 1.5 times 1.5. So 4.5. Would it be 13.5?
Yeah.
Okay. 13.5 times. All right. Does everybody kind of remember how to do that? Yeah? 1 times 1 things? It's a fairly, if you don't know how to do that, it's a tricky thing to do. Just as a general word of advice, if it looks like there's no numbers involved and you just cannot work without numbers, then just make up some numbers. Make them simple numbers, but just make up some numbers, like 1s and 2s. All right? Just make something up. All right. Next up, what about circuitry? Y'all remember circuitry? Okay. So this will be the last topic I go into today. All right, pause.